So, good afternoon, everybody. From Singapore, I just wanted to introduce today's lecture, which is New Tools in Architecture and Urban Simulation by Jan Halatsch. And before we go to that, I just wanted to walk with you quickly through the past lectures again to see where we are in the whole course today. So the first one, of course, was the information architecture, and we just go through the different podcasts. Very proud of the people who did that all the lectures are recorded now in podcast. I think this is the most complete semester that we have, although we tried many times. So that was the first one, the overview. Then the second podcast that you will find is the lecture by Daniel Aliaga, who told you about these very practical applications of information architecture in their work in the United States, in Purdue University. And he also presented his newest software. And if you need to know details about it, I think it's always good to go back on the podcast here to look at the names and the different applications. Then the third one was by Stefan Müller, Arizona, who gave you the introduction to the architecture of information. And you can always see the attendance of the different classes in the background. This is very, very interesting. Then on the fourth lecture, that was your input, because we looked at the design work or the exercise that you had done to give us example for sustainable information architecture in your view. And this collection is also quite striking. I hope you can be going back to these different examples in the next months and years and look how you judge them now after you have followed the course. In the fifth one, we concentrated, that was the first of the theory and experiment and simulation lectures. We looked at the differences between simulation, experiment and theory, and on the things that you can actually measure. That was the example with going back and forth between Singapore and Zurich and all the many, many tons of CO2 we saved by giving the lecture this way. Then in the sixth one, it was data mining and crowdsourcing, where we had new material coming in here from Singapore that had never been seen and shown before, so you were the first ones to see that. And this work is now getting very important actually here in Singapore. Then the seventh one was design, modeling and simulation. This combination of new words for some of you, but a very important contribution of moving simulation into reality. And the eighth one was also a quite new one, stocks and flows, that maybe many of you hadn't thought about before. But this concept proves to be very stable and very robust here in simulating the future of cities. And finally, last time, the Future Cities Laboratory, the presentation, what we do in practice with this information architecture here in Singapore and in other places. So that is the last one recorded. I don't want to make it much longer. I just wanted to tell you that we have a lot of publications coming out. So if you look at the website, please look at the new publications that are coming out in Chinese if you want to read it this way. We are also getting more and more publications from other people, like this golden book that just came out. This is the Design Awards of Design Singapore, and amongst these works that you find in there is the work that was given the first prize this year actually, from Design Singapore. And this is this building that you have seen many times by Moshe Safdie. You see this big floating deck over the city of Singapore, the emerging city of Singapore. So with that, I want to conclude the overview. I want to also remind you or announce that next semester we will have the course again, slightly different of course, but in the spring, either in March or in April, we will have a big event for all the students of architecture and civil engineering to show them more concretely what we do here in Singapore. So please tell your friends and come to this event, which will happen next spring. The date we will announce in the right time. So with this, I want to close here. I want to thank you very much. I want also to ask you to fill out the review sheets at the end of the course after Jan Halatsch gave his presentation. I want to present now Jan Halatsch. Jan Halatsch has been with us for a number of years already, and he came from Konstanz, from Germany first, and he was one of the very important people for the design of the Value Lab, so he actually knows quite well what he's talking about. And also he has been going into the software that you will see today, that he will put, showing you, in the production actually of the software very early on. So he has been a very stable source of information, contribution, also of new research projects with the KTI. He's leading one of them. And with that, I'm very happy to give Jan Halatsch the word and wish you a very good lecture. Herr Halatsch, it's all yours.
Yes, thank you very much.
See you.
Yes, see you.
Okay. See you. Bye-bye.
Bye-bye. Bye-bye. So, hello. Today I want to show you something about what could be the next trend in city modeling. I will show you some techniques that are called grammar-based modeling techniques. Where you actually can recreate a lookalike city of an existing city, and where you can make certain evaluations as an architect and find out how does a city perform, how does a city actually make sense to your design proposal. And I want to show you some of the first steps, what we are doing right now, and give you some hints what are actually the techniques behind the nice pictures that you can look at the city models. So we have some motivation, we have some about this modeling process and this technical things, and we just go right into that. If you look on this kind of future cities as they are growing extensively, for instance, here in Midwest China, Chongqing, a city which is like only 30 years old, is about the size of Austria and has a population size of 60 million people. And if you look from far away, oh, actually that's not Chongqing, it's a typical picture, it's Shanghai. If you look from far away, actually it looks like a modern city. Well, this is Chongqing, actually. Sorry. And if you go then down to the details, even having in mind that these cities had been planned with quite recent tools of urban planning and urban design, you see there are certain kind of caveats where somehow it didn't work out so far. For instance, with the infrastructures here, there's some, maybe it's just about regulations, maybe it's about aesthetics, or that somebody really didn't recognize that there was maybe before a more rural society, farming activities, and then it suddenly shifted into high-density housing units. But some certain habits that are originated from this area, they need to be maintained and they need to be recognized and put into architecture. Otherwise, people will do it like that. So this could be a thinking model. But how to actually cover all this kind of little things that come actually to that and to arrive at future cities? I mean, the one thing is that you have such a nice pictures here of Burj Arab and all the other things around, but this is just a picture. It doesn't tell you so much. It just gives you a first vision. It doesn't tell you what are the ingredients, what is the ecosystem of your city. How actually will it be interconnected, all the little things, the different kind of land use mixes and so on, the numbers if it comes to the real estate developer, or if it comes really later on, for instance, to ecological systems. And therefore, we have kind of very traditional thinking models. At the moment, urban designers and planners, they basically work with evidence-based design. So what I know, that it worked for the last 30 years or failed, I try to do my best to make it better and make a design proposal. And maybe sometimes I use a tool to know something more about that. Another approach is that you, from the very beginning, you use analytical tools to find out about what are, like on the regional scale, what are my ways, for instance, how much time does it take to get from the outside to the city center and so on, or what is, for instance, the shading envelope For instance, in areas where you have a high sun exposure, that you might want to increase actually that. And a new technique or trend is that you gather insights from the public or from a broader mixture of stakeholders, that you have a kind of participation inside your design. What are the benchmarks? And these are actually the new trends developing, that you combine with benchmarking tools with the knowledge from the people. And one of those techniques are, for instance, used in one of our research projects here, NRP65, to set up the requirements, what are the potentials or what should be necessary for the Limmatal Valley in the next 30 years. What are the development scenarios? That you make interviews and that you just don't do it alone as an architect. We have common architects inside this project, and you need to do it with transportation planners, with social planners, with ecologists, and so on. Some of the procedures that we do here, just directly from the project. So for instance, we need to know all about this different kind of rules and criteria, and we want to set up and feed it into a digital model where we can see this could be like the visualization of all those thoughts. And with this visualization, we have a tool which understands everybody else, because the city model is something what we know. We know it from looking at it while going through a city, or from looking at from a map or Google Maps, for instance, and we can explore that. And if we have it along with kind of indicators, for instance, what does this particular block tell us, beside all this kind of aesthetics that we, of course, need to react on as designers, but with all these indicators, we can know about how much is it about ecology, how much energy is spent there, and so on. And that, how we do that, we have to set up a system, we think, so that can be later on, maybe in the next 5 to 10 years, can be used to really use it in design in daily practice. So this is one of the case study areas. Some students in the other course, they have to work on that to create such kind of a procedural model. This is just a section of Altstetten. And this is just a comprehension, what are the steps. So we think on the one hand side, we have all these participative aspects. Then we have to find about all the design experience and to evaluate the performance, and together actually to make a loop and go again through all the cycle. So, but how to do that? We think interesting approach is actually to not just to formulate the shapes, but to formulate what is the shape actually doing and how does it react in a context. And one approach is to do that are design grammars. Design grammars is actually something very old. We used it already to design Greek temples as architects. We had a formulation of all the kind of combination from the massing or the formulation of the columns, for instance. But it is even used rather intuitively, for instance, here in Medina, how the organization of typical houses are done. So, for instance, we have always, like here, a courtyard. We have some building around, and if you go into detail, you could say a grammar is something what you like to formulate, that you have defined string in the end. If I speak a sentence to you, I have a defined sentence. It tells you hopefully something. You can do the same with shapes in architecture. You can use it in developing websites, for instance, as a CSS style sheet to some extent. It's kind of similar. So it's like a rule set, what you gain there in a defined manner, and to create or have a control about the design what comes up later on. So we use it to describe spatial configurations, but as well to put in not just shapes and geometry, but as well to put inside, for instance, things like population density or land use, or what is it actually? Is it something like a street, part of a street? Is it an open space? And so on. Yeah, actually, to be honest, we didn't take the direct way from all the knowledge that has been already used prior in architecture. There is like a way around, like a little excursus to computer science, where actually grammars had been used kind of a lot, especially shape grammars. And to make it just very short, actually you have a set of kind of start symbols, like I'm a lot, I'm a street, I'm a block, or whatever. And you have an alphabet where describe something inside. And then production rules to transform shapes. And in the end, all these things together are an assembly of a kind of language. For instance, your personal open design draft. So we start, for instance, on such kind of string. To define such kind of string, we start with a start symbol, makes sense. And then we have rules that just come after each other. So this is a bit piece of theory here, but to just make it very simple, is that you have seen it once in a while, how it actually works in the background, that it not just comes out automatically, that there is some meaning behind it. For instance, you have your set of start symbols, for instance, just one S, you have one A, one B, and you have two rules. So for instance, the rule is like, if you have a start symbol, then in the end, the production rule says, okay, we have an A, large S, and a B. Or we have a second rule, like S evolves into little b and A. So then we have a possible set of production, like this. For instance, we start with the first rule, this one, and then for the next one, we will see, there's another S, so another start symbol, and then we just reapply maybe the first rule, then we can just exchange the S with the ASB again. And then as the next step, well, maybe we just want to finish this. We go here and say, okay, our S is like BA. And the interesting thing is, with this kind of sequences that you have here, you could already say, maybe it could be like a sequence of architectural shapes. Maybe it's just a piece of a facade, a very distinct one. Okay, and if you, for instance, just reapply, in case this kind of rules for longer examples, you just get always like these very structured sequences of symbols here. This can be then put into the context, that is the language of this grammar. Okay, we have different other examples here. I don't want to overstress this. And in combination with a tool like City Engine, you don't just have like text, like this ones. You describe actually 3D shapes. Where to place this box here, this box, and maybe this column here. And then you have already like the massing of the Sternwarte next in the ETH10 tome. Very nice one of Semper, you should see this. And in combination with other extensions of these rules, you can even say, okay, with this modeling, this very abstract modeling, I can describe concepts of a ground floor. So I have a rule called ground floor, and maybe some structuring inside that I want to have a ledge, and over that I want to have a floor. But even if I'm not knowing how actually high is my building, since I have just maybe like 100 lots, and I don't know, maybe some are 10 meters high, some are 15, then you just have like a parameterization that automatically, if it's getting higher, then you just insert new stories. So the computer does it for you automatically. So it doesn't matter if it's just so small or that large, maybe a bit wider. So you don't get any kind of distorted geometry. You just have a complete facade. So if you look at this kind of particular shapes, they have a logic inside. For instance, this shape here is describing actually the prototype of the Medina subdivision patterns, of the parcel of Medina. So you could say, these are certain kind of distance functions. Maybe the red one is a building. And if you see how many combinations are possible, it's quite flexible. So for instance, you could describe stripes, you can describe L shapes, whatever. And with that at hand, you can easily set up like a set of little kind of design patterns where you can configure your building typologies that you have. And after defining that and setting up your urban master plan, you can just apply it to a DXF, for instance, using this tool City Engine, and just create a city model. And therefore, it's just important to know that you are designing a pattern of a a specific shape. And these patterns can be put together as a set of different kind of patterns, maybe description of some land uses and so on. Oh, that's fast, it was not me. Into a whole grammar, and coming from there. So the special slides, they are moving faster than I do. You can even say you could have different kind of variations of it that come all from different kind of architects, designers, and you can mix it even together. So it allows a lot of flexibility here, actually. To do so, you need to find out what are the most specific scales that you're using. So for instance, you have, of course, a regional scale, you have, of course, a block scale, and you have the single building in the end. And if you set up such a kind of construction rightly, you really can describe a whole city, or at least a block where you want to do your master plan. So that's just an example how you can actually go from large scale to lower scale, so actually all those kind of patterns are combined and put together. So this was very abstract. Maybe I can put some light into it. If you see just at a drawing, like this urban visioneer Corbusier, and this cruciform skyscraper was one of very, very nice ideas about restructuring Little Paris. And so there was a bit of sarcasm here. And so, for instance, here, if you look at this very geometric form, you can identify there are certain kind of very regular pieces inside the shape. So it's a very easy example. In that case, you just need to modify and alter the 7 attributes here, and then you can create such a skyscraper, and you have maybe these variations because you have different kind of contextual inputs like sunlight and so on, and the shapes of the skyscraper can align to that. So, of course, you can add textures and so on. But maybe now from the next thing is why this modeling technique is so powerful. You can relatively easy get from a just 2D data set to a 3D model. How to do so? So for instance, you have like an input. Here you have some satellite imagery. You have some building footprints or parcel lots. And then you can define some simple rules. Okay, if I have like this lot, it has the area size of X. Maybe we know what kind of land use is. Maybe rather typical that this building is maybe just 12 meters high. Or for instance, we exactly know from the data set, for instance, the roof height is known that this building will be like 16 or 20 meters in height. You can just automatically assign a very simple rule, like extrude 10 meters, or extrude height from GIS data set, and then the value will be read and used for extrusion. Or even if you have more information about the roof, then you can read maybe from the database what kind of roof types are existing. Then the roof will automatically be placed on top of your block model, and maybe accordingly to the preset types that are inside, you just have the roof on top, and maybe you can just texture it directly with the satellite image that you have underlying here. Then you can make different kind of visualizations. For instance, what are the land uses, and you can explore in 3D how it looks like. So, on the building level, you can use this parametric description of those rules to easily define or to find out about the building shapes. So maybe I can just go forward. So how you want to have a kind of detailed facade. Maybe you have a rule for your area that the penthouse needs to have a setback. Maybe it doesn't need to have a setback. Or the windows need to be different, or the building needs to be higher. And you can just adjust, and it will adapt. So, okay. So you just set once the model code, then you have your GIS data, and everywhere where you have the building type A, it will just come up automatically. So, or for instance, you can just generate a whole city. So we need to update this wrong year. And yeah, then you have actually, this case you can set it up, for instance, that in the first step you have just only textures as facades, and then you can increase more geometries depending on your users. And you really can already have a street-wise, street profile-wise evaluation of the area which you're in. Or for instance, you can make modifications to an existing design. For instance, you just make an appendix to something else, and automatically it will be generated according to your definitions. Or you can look, how does it look like to just introduce a new street, for instance. Of course, it doesn't make sense for Paris, but yeah. So just imagine you do this with styropor foam. Okay, so basically you just have a definition of common building typologies, and according to these building typologies, you can maybe define setbacks and some other rules, and you can even do some reporting on that. Okay, this was like kind of redundant. So, next example. We use it actually a lot already, this kind of tools, and we developed these tools as a partner of the former company Procedure, which is now Esri. And for instance, one of the first case studies where we used it was in Mazda. Mazda is maybe known by you. It's the first, or claims to be the first CO2 neutral city. And one piece of the city is called the Swiss Village. And inside the Swiss Village, we had to make an evaluation of the passive design guidelines of Foster and Partners. And therefore, you try to set up somehow something which is expressing actually the design guidelines of Foster and Partners, and then you translate it to a city engine model into code scripting. And some of the things like the carvings on the top helps the airflow, and some of the things like covering the facade helps to enhance privacy. So for instance, here it's a good example of having like physics involved, urban physics involved, and as well like social issues that you have there on the particular market in the Middle East. So some more pictures, evaluation of the model. And what we found out, actually it's behaving quite well. The only problem that they have is with acoustics. So that basically, next thing what you can do with that kind of models, it had nothing to do with design in a kind of shape way, but for instance, what is the eco-design of these areas, which is very interesting. If you set up a new building on a brown field or a green field, whatever, in this case, you have desert field, whatever, you have the problem that if you don't care for the actually for the habitat, you will just get any kind of species that you don't want to have there, like rats, for instance, mice, maybe. And so they plan for that you can create the habitat for desert hares and certain kind of birds. These are the key species. If you have the habitat for those two key species, there will be automatically all the others, so in theory, as well be there. So there had been like a conditional rule set to find out where inside these blocks these habitats are fulfilled. Green is fulfilled, yellow rather not. And so you can use this as well to find out about some logics in ecological design. So these are some student works from our courses here, where they as well investigated the patterns of Mazda. If you have all this knowledge at hand about all these building blocks, shapes, and you can all do this kind of things, you can go the next step. You can find out what is actually further inside your city. So if you have the combination of design, you have like a data set from cadastral office of Zurich, you can automatically maybe reconstruct a lookalike model of Zurich where you already know something about it, not everything, but for some calculations may be good. And you can find out about, for instance, what may be the energy use or the CO2 emissions inside your city quite rapidly. So for instance. This is one field of application. And then you can see, or maybe you can communicate to others, for instance, like Credit Suisse is not working so well, and maybe you should do something about that. Okay, maybe you see one little mistake in this visualization. Of course, the Hauptbahnhof is not so bad, the main station, as it looks here, since it's just an open hall. Yeah. So the green ones are the amount of energy used in kilowatts, megawatts, you know. And the yellow ones are the CO2 emissions in tons, and just on an annual basis. Okay. The next thing is, if you have something like that at hand, maybe you want to know, how can I shift my society, how it could perform better, and how does it look like in a built environment? So maybe if you want to have a city of compact building blocks, maybe a city of short paths, or you just cover long distances with a high-speed train, and you want to produce your energy as much as possible locally, how does a city like this look like? For instance, Zurich. Maybe it looks like that. Everything is very compact. You have very, very compact building shapes. Maybe you have, even on this cultural heritage places like the Zürichberg, you have wind farms. I actually don't want to have them right now, but maybe you need to have them later on. And this is not to be mistaken as a design draft. It's just a visualization. It's just an information visualization in a real-world context. So this can be used to start to talk about future scenarios and to make proposals. So, how much time do I have?
10 minutes till the end of the lecture.
Actually, I'm over time. Good. Okay, so I just go. I'm always already finished already. So, and this, I mean, these pictures are maybe nice, but actually you want to have this kind of visualizations while you're talking about them. You're actually proposing the design, as the same way actually you're placing styrofoam models on a table, on a plan. You should have that available in real time. And if you do something wrong, maybe something is getting red or whatever. Maybe such a table like this, you have this visualization at hand, at place, and you do it in real time. Okay, this picture was like 16 hours rendering and with a good computer, but actually we don't want to have like 16 hours. Actually, we want to have it just in real time. For instance, we have this example here, one of the results of our CATI research project. For instance, Rotterdam Haber. You just have a web browser here, and you have the model inside. And these are the first steps. They can, in almost like one-to-one photorealistic picture, can be just instantly generated from a web browser, from a computer like that, but as well like just a simple mobile phone can be just rendered online. And we are just working on that we get new tools inside that you can go there and move a building somewhere else or make it smaller because you see that the envelope is too big, the shading envelope. And some people online can look from home on these proposals, what the designers are doing, and can vote maybe in Facebook, I like, I don't like, whatever, and really shift and change. It sounds to be very abstract still right now, but actually we're not so far away from this technique. Maybe in 18 months, we're getting closer to that one. So this is all this grammar-based design or modeling thing. And if you want to know more about that, next spring there's a next advanced course. And if you like to be there, I would be very happy to see